So yes, so basically, before this we have looked at apa? We have looked at different types of atomic and molecular spectroscopy. So you have learned on the different kind of spectroscopic instruments. All right. So now we are going to look at on the sample preparation for inorganic analytes. Okay, macam ni lah. The easier way to look at this is that for inorganic substances or inorganic analytes, it is usually being analyzed by using spectroscopic methods. Okay, spectroscopic methods. But for organic analytes, it is going to be using chromatographic instruments, which you are going to learn after this chapter, chapter 6 until chapter, if I'm not mistaken, chapter 11 ke macam tu lah. Alright, so you have two or three instruments of chromatographic. Okay, so for this chapter, chapter 5, we are going to look at on how are you going to prepare the samples for inorganic analytes. Means that for apa? When we are preparing inorganic analytes, it is for what kind of instrument? Ada answer tak? What kind of instrument? Anyone? Aidil Hafiz. Aidil Hafiz ada ke? Aidil Hafiz? Tak ada.
Dengar tak?
Dengar. So, for what kind of instrument kalau inorganic analytes?
Emission ke apa?
Saya tak dengar apa?
Emission.
So, for inorganic analytes, it is used for spectroscopic analysis. Okay, spectroscopic ni yang tadi tu lah, absorption, emission, okay? Even ICP-MS pun, it is a spectroscopic methods. Alright? Okay, so moving on, we are going to look at different kind of sample prep for apa? For different kind of equipment or spectroscopic instruments that we have learned before. All right. So I've also moved on to the different criteria of how are you going to choose what kind of instruments. So now you would need to imagine yourself receiving the sample. So you have learned during chapter 1 lagi, you have learned on how to do the sampling process and how to do the sample preservation and storage. And then you have learned on different kind of instruments. And then now you are going to do your sample preparation prior to the instrument analysis. So you have learned about the instrument. Now you need to decide, which instrument that I'm going to use based on whatever resources that I have. Okay. So basically, these are the criteria which is good for you to know, to think about of, for example, if you want to analyze multi-element analytes. So, for example, kalau you want to analyze multi-element analytes, which instrument you should go to? Anyone? Anyone want to try?
Doktor,
Yeah.
yang ICP-MS tu.
Yes. So usually for thank you, siapa nama tadi? Saya tak dapat tengok. Nur
L. NRL.
Okay, Nur Al Ain. Okay. So basically yes. So untuk multi element analysis, so you straight away go to ICP-MS ke ICP-OES. So it depends. Okay. So if you want to use for example, okay lah, I just want to analyze copper. So somebody came to you, okay, L, Ain, I want to analyze copper only. So you need to use a single element analysis, which is either FAAS ke, you nak guna graphite furnace FAAS ke. Okay, so it depends on your decision. In even your detection limit also need to play a role. Okay, detection limit here is that, okay, if you are moving towards the left side, kan, detection limit tu it is more towards ppm, part per million, means that it is not that low detection limit dia. But if you were to go to not higher lah, lower detection limit, you need to go to much more higher end lah, which is ICP-MS. So it depends. Okay, this detection limit usually comes like this lah. Okay, okay, Nurail, apa? I have this sample which is copper. I want to analyze copper, but it is in trace analysis. Apa? Trace element analysis. So if there is word trace, trace means that it is needs the detection limit need to be lower. So if that's the case, you straight away go to much more lower detection limit, which is in this case ICP-MS ke, graphite furnace, something like that. So that's how you try to decide on your apa which instrument that you are going to use based on the information that you have and your resources lah. Okay. So for example, if your lab later on, for example, when you work at apa and at an oil rig ke later on. For example, if you have flame AAS and you have ICP-MS, so you have both ends. You have the lower end, you have the higher end. So, but your resources, kalau you use ICP-MS, it's going to be much more expensive than using FAAS. All right. So that's how your decisions should come through. Okay. All right. Up until this point, do you guys understand on how to use this chart? Faham tak? Faham ya? Okay, let me look into the chat. I believe that there are some question. Doctor, does the detection limit decreases from FAAS to ICP-MS? Yes, the detection limit decreases. So detection limit decreases ni, it doesn't mean that it's not good. But when the detection limit decreases, it means that it is much more sensitive. Okay, detection limit decreases, it means that we go from part per million detection limit to part per trillion detection limit. It means that the instrument is so powerful that it can detect an analyte at a part per trillion concentration. Alright? Alright. So, okay, so if everyone understand, that's good. Okay, so these are the another chart for you to look at. Okay, and then these are the apa? The table that we have been looking at before. Okay, the different type of atomic absorption, atomic emission ke atomic spectroscopy lah. Okay, alright. So, okay, for this lecture, I have gone through until where? Do you still remember? Whoever have watched the video, where have I stopped?
Dry Asian.
Ashing okay. Thank you, thank you. Alright. Okay. So ashing. Okay, so ashing is for you to prep your solid sample, kan? Alright. So dry ashing, okay, let me start here. Alright. So dry ashing is that you oxidize it by slow heating in oxygen at a very high temperature. So the temperature increase up to 700 degrees Celsius in the furnace. Alright. So involved in the incineration of food samples lah. Usually we employ this for food samples because in food samples usually they have a lot of organic material. So now you just want the inorganic material. Okay, so it leads up to the decomposition of organic matrix, which resulting in the inorganic residue, which is that's what what you want, isn't it? You just want the inorganic residue. You want the inorganic analytes in your sample, not those organic. Organic material too, you are going to learn that during the second part of the semester. All right. So this temperature can be too high for volatile metals such as mercury, arsenic, selenium, and lead. Okay, so other metals such as tin may form insoluble refractory compounds during dry etching. So these are the downside of the dry etching as well. So if you, for example, people come to you, okay, I want to analyze, I suspect that in this sample there are mercury, arsenic. Oh, in that case, you cannot use dry etching because these dry etching methods are going to make your analytes much more volatile pula. It makes your analyte volatile. So it will evaporate, means that your analyte will disappear. Okay. So you need to think about another type of sample preparation. All right. So the addition of etching aids, so in this case, for example, salt of metals or acids may improve the efficiency of etching and to assist the recovery of certain element. All right. So usually for example, when you look at this figure, we weigh about 0.5 gram of fish sample. All right. So we heat it in the muffle of a furnace about 600 to 700 degrees Celsius, 7,000, I think 700 je. Okay, 7,000 tinggi sangat. Alright, and then we dissolve it in dilute strong acid. So this is how, so that whatever that we have in the residue that we have in from the furnace is your inorganic analytes which we have dissolved back into the dilute strong acid. Alright, alright. So apart from dry etching, we also have digestion techniques. Okay, so as what we have looked at dry etching, there are some material or there are some analytes that cannot be used dry etching. So what are the other techniques? So maybe the digestion techniques is the answer. Okay, digestion techniques. Okay, so digestion techniques is the for accurate decomposition, which is the destruction of organic matter in food sample. So as this is for food sample as well. So we when we are trying to prep the sample for inorganic analytes, you need to straight away think that, okay, I want inorganic analytes. So inorganic analytes, uh, it is much more heat resistant as compared to organic analytes. Okay, so basically whatever that you are digesting or you are etching, yang kita belajar before this, you are trying to destroy all of the organic material because this organic material will make your analysis much more harder if you want to analyze inorganic material. Okay, so that's why when we look at dry etching or digestion techniques, we are destroying the organic matter because we don't want those organic matter to interfere with your inorganic analysis later on. Okay, so why decomposition is required? Why we want to destroy this organic matter? Okay, we want to convert the solids into liquid. All right, so when you imagine that those fish samples, so for example, you take the fish flesh. So what now we are trying to convert the fish flesh, which is more or less like a solids, to into a liquid, and the liquid must be as clear as possible because kalau liquid tak clear maksudnya apa? Is there any idea? Kalau kita liquid yang tak clear tu. Any idea tak?
Tak fully dissolve.
Tak fully dissolve. Means that tak fully dissolve or there are some suspended solid left inside the liquid. Means that bila ada solid, kan when we are trying to use the AAS ke, ICP-MS ke, dia aspirate kan. Dia ada proses aspiration where you need to nebulize and then you need to change it into the atom state kan. But when there is a solid present inside your liquid sample prior to analysis, then it will be stuck into dekat tube tu, dekat station tu. Okay, that need to convert your solids into liquids and make sure your liquids must be as clear as possible. Okay, if it is not clear, it means that you need to filter it. Some sort like that, okay? So that's why this some solids ni, semua solids ni may be due to the organic matter still present in your sample. Okay? Alright, so now that is the conversion of solids into liquids. We are going to look at into the destruction of matrix as well. So when we look at into the fish samples, we want to destroy the matrix other than we don't want anything other than inorganic analytes, which is not in the matrix. So we want to destroy the matrix. Okay. We also want to separate the interfering substances, which is maybe isoformation of sample and the standard. And then we also want to for it to be homogenized. So now that's what I meant when we want to turn into a clear liquid, which is homogenized. Homogenized means that it is just only the inorganic analytes and the acids, which is the one that we have dissolved it in. Okay. And then we also want to pre-concentrate analytes. Okay, pre-concentrate ni, anyone understand tak? What does it mean by pre-concentrate? Any idea? Ada idea tak? What does it mean by pre-concentration?
We reduce the other content that we don't want beforehand.
Okay. Not that accurate. Tapi I get your idea. Anyone else? Ada idea lain? What does it mean by pre-concentration of analytes?
Doctor, maybe just a way to increase the amount of analytes.
Okay. Yes, you are correct. Increase the amount of analytes. But how are we going to increase the amount of analytes? Means that now, okay, you imagine that, okay, for example, you've got your liquid sample. So that the people came to you, okay, I have 1 liter of river sample for you to analyze for the mercury poisoning, for example. So you cannot have those 1 liter, even though it is a clear liquid whatsoever, and you can just aspirate it into the into your instrument, but it is 1 liter. 1 liter of river water. So you cannot have all those 1 liter into your instrument. So you need to apa orang kata tu, you need to minimize the volume, which when you minimize the volume, you suddenly pre-concentrate your analyte. You get what I mean? When you, for example, when you make 1 liter of 1 liter of cordial, orange cordial water, but when you left it for a few days, the water will evaporate, and for example, it will be left at 500 ml of cordial water. The taste is going to be much more intense in those 500 ml cordial water as compared to 1 liter cordial water, because the solvent has been evaporated. The water has been evaporated, leaving your orange cordial inside your water tadi, inside your sample lah. So that is how the logic behind pre-concentration means that you evaporate the solvent. Kalau evaporate the solvent, you eliminate the solvent and you pre-concentrate your analyte, because your analytes would not be evaporated. Okay, your analyte would not be harmed in this process. It is just for you to do the pre-concentration, means that you evaporate your solvent, leaving your analyte much more intense inside, or much more concentrated inside the sample for the analysis. Okay, faham tak for the meaning of pre-concentration? Anyone? Faham tak? Ataupun tak faham sangat?
Doktor,
Ya?
kiranya macam nak biarkan yang sampel tu dia jadi pekat lah, bukannya jadi macam cair yang ada water dalam tu.
So you want your sample to be as concentrated as possible daripada the large volume that you've got. For example, kalau kita tengok tadi my example of river water, you have 1 liter of river water, but of course dekat dalam tu it is not 1 liter of of analytes. So there might be some trace analytes dekat dalam river water tu. So when you pre-concentrated it, your detection limit is going to be much more higher. You faham tak the logic behind it? So bila you pre-concentrate it, for example from 1 liter you convert it into 100 ml. The concentration of your analyte will be much more higher as compared to the concentration in 1 liter of salt of river water. Now you have only 100 milliliter of river water but contain the same amount of analyte as opposed to with those 1 liter. So your analyte is much more concentrated, then it is much more easier for it to be detected by your instrument. So secara tak langsung, your detection limit is going to be much more higher as compared you are 1 liter river water. If your detection limit is much more higher, then based on those criteria, which instrument we are going to use? Any idea?
FAAS.
Betul. That's correct. So when you have increased your detection limit, then you would have the choice of using the much more much more cheaper instrument, which is the flame AAS. Okay, if you have trace analysis, if you want to analyze, for example, you don't want to concentrate the 1 liter river water, you need to use ICP-MS because it is in trace amount. But when you have pre-concentrate it, then you have the availability to choose to use the flame AS, which is much more lower cost. All right. Okay. So understand tak for that part? Understand ke? Okay, good. All right. So okay, here are the pros and cons of digestion technique. So pros is this, it leads to a much more representative sample. It reduces problems in the measurement step. It is easy to standardize. Okay. The cost is that the cons is that for digestion techniques is a labor intensive cost factor because you need to use microwaves. Okay. It is not a cheap instrument. Bottleneck in the analytical process. Sometimes you have a elimination or losses of analytes due to the digestion. Okay. All right. So now we are going to look at the different types of digestion. All right. So now we have wet digestion. So wet digestion is by using acid treatment. Okay. So it is at low cost but may lose analyte by volatilization because we heat the analyte lah. For example, if you are using HCl, it is for carbonates, phosphates, and oxides. So if you are using sulfuric acid, it is for organic material 300 Celsius. All right. So these are the acids that you can use to analyze different kind of materials. Okay. So the grades of acids. So basically the acids ni, the one that you are going to be using for wet digestion must be a very high purity. Okay, it needs to be some sort mainly 100. There is no 100% acid, so you need to have a high purity chemical particles. High purity, no other interferences inside the acid. Okay, but if it is a very low, for example, the acid is at low purity, then you might have other interferences in the acid. So when you have interferences in the acid, when you put inside your sample, then it will introduce a new interferences for your analysis later on. So that's why we said that your your acids must be at high purity. All right. Okay. So, I think that after this, we are going to look at the procedure of digestion. So, the digestion ni, itulah, as I said, that it's going to be using acids. So, digestion techniques, digestion, the decomposition is safe for analytical, accurate, and then it is economically efficient because it's just using acid, and it is safe and easy to perform. But as I mentioned before, there are cons inside in these digestion techniques where it may introduce a new kind of interferences add to it. As compared to dry ashing, you just heat it up, but you also have a cons there because you cannot heat every little element inside the furnace because some elements might be volatile. Okay, so uh, alright, so this is digestion techniques. Kita tengok kepada alright. So this is the sample preparation equipment for digestion. Maybe you may use a hot plate. Okay, you just put your sample inside here, inside the I actually maybe a conical flask, but it's much more longer conical flask. Okay, longer neck. Alright, so you put your sample inside here, and then you put your acids in. So you heat it up. Okay, or you might able to use a microwave assisted digestion where you put your sample inside. There are tubes inside here. So you put your sample in, you put your acids in, and then maybe you have a digestion block which it will measure the temperature, which be much more uniform. Yes, uniform from one another. All right. So most samples have to be prepared for the analysis of ICP ke, flame ke, ataupun atomic adsorption. Solid samples are solubilized. Organic matter is mineralized, which is converted to inorganic compounds. So your organic matter now is being destroyed. Okay, right. So now, okay, we are going to look at a method which is this is a standard method. Okay, a standard method means that the method that has been proved to be useful and proved to be reproducible. Okay, for the determination of cadmium in fish. Okay, so method ni standard method AOAC 999.10, which is a closed digestion punya method for the determination of cadmium in fish. So basically it's for solid sample. All right. So you weigh 0.5 gram of fish sample or balance. I believe that you already have your lab kan this week. Dah ada lab ke?
Not yet. Next week, got it.
Next week Okay. Okay, next week kot. Okay, betul lah. Alright. So, when in the lab later on, they are going to show you on how are you going to use this analytical balance. Have you been pernah guna ke analytical balance sebelum ni?
Introduction dah lah tu, just the experiment doesn't start yet.
So yeah, so in the introduction they have shown you on how to use the analytical balance. So analytical balance is very powerful in terms of the weighing scale lah, because it is up to 4 decimal point. Okay, so weigh 0.5 gram of your sample, which is in this case they have been chosen at the gut. Okay, the gut portion of your fish sample. Right, so you 5 ml of peroxide H2O2 and 5 ml of nitric acid into your sample. So basically, this is the digestion, the start of the digestion process. Okay, we have been using peroxide and also nitric acid. All right, so we cover the seal cover it tightly. Okay, and then we put into the uh, this instrument of where you can place the temperature and pressure when you can decide lah on what temperature and pressure that you want. Okay, and then it is been left for 45 minutes. So in this instrument, your digestion process would start. Okay, you place it so the temperature would aid in the digestion of your organic material with the help of the acids as well. All right, so after that, you transfer it into a 25 ml of volumetric flask, and then it is ready to be analyzed. Okay, understand that for this method? This is the overview of the method lah. If you want to look at into very detailed, you can just search on the this AOAC 999.10 method. Okay. All right. So this is a closed digestion methods where closed digestion it comes by its name lah. So you close it into a tube where you cover it very tightly, and then you put it into the instrument, microwave instrument, where you have a certain temperature and pressure for it. Okay. How about when we don't have the microwaves? Okay. When we don't have the microwave. So this is the method for an open digestion method. You just place it onto the hot plate and stir it so you can straight away do the digestion. So basically it's the same with 0.5 gram of sample, and then you place your peroxides and nitric acid, and you put it onto a hot plate below 95 degrees Celsius until a clear solution is formed. All right, so clear solution is formed, or even after this maybe you need to just get the clear apa orang kata tu, the clear part of it. Okay, if there is any suspension, you just need to get the clear part of it. Okay, so transfer it is the same as what as before as the closed digestion, which you transfer into 25 ml of volumetric flask, and then you dilute it, and then it is be ready to be analyzed by your any spectroscopic methods of your choosing lah. Okay, all right, so that is for solid sample. Okay, so any question for solid sample before I go into liquid sample? Ada soalan ke for solid sample? Is there any question?
Apa tak ada dah.
So far tak ada. Alright, terima kasih. Okay, saya move on to liquid samples ya. Alright, so liquid samples, aqueous samples can be generally introduced for analysis directly without any prior treatment. So liquid samples usually if without solid suspension, so usually liquid samples ni you can just straight away do the analysis. But usually in my opinion that maybe if it, for example for my example just now, if you have 1 liter of river water, you cannot just aspirate 1 liter inside the FAAS. Okay, you still need to, maybe you need to do some pre-concentration method to it, so that maybe only 25 ml of those 1 liter sample to be aspirated into the flame AAS. Okay, all right. Okay, so maybe I'll just move on onto the APA 3030E. Okay, so this is the determination of cadmium in wastewater. All right, so use wastewater sample preserved in 5 ml of nitric acid. So this is for This is for when you have learned your preservation punya method. usually sample ml of nitric acid per liter. Okay, this is the preservation and the storage method that we have learned before. All right, so homogenize the solution means that homogenize in terms of make sure that the if there is any suspension solid at the bottom, you just stir it. All right, so homogeneous the solution, and then you pipette 100 ml of solution into the into the closed tube. Sorry, this is for open digestion. All right, so for open digestion, you just place the 100 milliliter of sample. Okay, so you add 5 ml of and then you heat it at 95 Celsius until from the 100 it becomes 30 ml of solution left. All right, from 100 ml to 30 ml, what does this mean? Any idea?
Pre-concentration of analyte.
Yes, good. Okay, so now you get the meaning of pre-concentration. So you change from 100 ml to 30 ml, and then you transfer it into a volumetric flask, and then you dilute it, and then you do your analysis. So means that now we have achieved the pre-concentration punya method. Okay, we change from 100 ml to 30 ml. So you minus 70 ml of the solvent itself, left with just your analyte inside the 30 ml of solution. All right. Okay, so that is for a liquid sample. All right. So microwave digestion, this is what I've said before. Microwave digestion, it is a rapid and efficient acid decomposition using microwave energy in a specially designed oven. So this is an example of microwave lah. You just put your sample inside the tube, and then you close it. So microwave assisted digestion usually it is a closed system lah. So you place it onto these microwaves. You set your temperature and pressure that you want, and digestion would happen inside here, rather than open digestion that you have looked here, where your your solvent is evaporated into the air. Okay. All right. So micro digestion, the advantages of it is that the sample contained is within the digestion level. So there is no evaporation of sample. There is no evaporation of solvent outside of the vessel. It is highly efficient and rapid. It is about 5 to 10 minutes. Okay. If you were to do open digestion, for example, when you want to reduce from 100 ml to 30 ml, it's going to take more longer time lah as compared to micro digestion. Okay. Volatile elements are retained inside the reaction vessel. That's what I've said before. It is easy to automate, and it is a computer controls the pressure and the temperature, so that you just put inside the microwave and let it do its thing. You don't need to sit in front of it. For example, for open digestion, you need to do it inside the fume hood, and then you need to look it as once a while lah, to see whether your reaction, whether your digestion is safe or not lah. Okay, if it is a very rapidly bubble, then you need to consider to maybe lower the temperature down. You need to use the thermometer inside the solution to see whether it has been reached maybe more than 95 Celsius. Okay. But for microwave, we don't need to do that because it is being controlled by the computer. Okay. Consideration. Okay, now consideration is that you need to think about when you use microwave, you cannot add any more reagent during the digestion. Whatever that you put inside it, that is the only thing that's going to be used. You cannot add more. For example, for open digestion, for example, you think that, oh, maybe I didn't put 5 mil, maybe I just put 2.5 mil. You can add another 2.5 mil later on. But for micro digestion, you cannot do that. You can open and put it and do it again. No. All right. For consideration, number 2 is that maybe it is for limited amount of sample. Okay, typically 1 gram or less. So if you have is 5 grams, for example, fish samples. Okay. Oh, when you put your, for example, if you want to use a much more higher fish samples, for example, 5 grams, so this is one is 0.5. But if you want to use much more higher sample, then you cannot use microwave digester lah, because it's typically 1 gram or less, right? There is also a concern of the safety because it plays around with the high pressure and high temperature. So you need to, this is part of your consideration as well. Okay. So you need to make sure that your microwave digester is being calibrated and regulated once a while lah. Okay. Maintained once a while. All right. Cost of microwave system also is going to be high if you are using microwave digester. All right. So, the other part, the other technique is that the fusion techniques. Okay, fusion techniques is one of the techniques for digestion as well. For you to just prepare your sample for inorganic analytes. Okay, the fusion techniques is that you mix your samples with a large excess of alkaline metal salts, which is known as flux, in a crucible and heat it at a very high temperature until the substance fuse together in a molten state. Okay, when you place your inorganic analytes, means that, for example, you place your fish sample just now, you place it with an alkaline metal, and then there is a ratio lah, 1 to 10 or 1 to 20, which is 1 sample and 20 salts. In a crucible kan you tahu something that you put it in, like a macam small bowl macam tu. Okay, you put it in and then you heat it up at a very high temperature until the sample and the alkali fuse together in a molten state. Molten ni some sort like a fluidic state. Okay, fluidic state macam when you look at into macam lava of a volcano said. So basically that is looks like a molten state. Okay, all right. So the molten state is allowed to cool at room temperature, and after that you dissolve it with dilute acid or water. Okay, that is how you look at the fusion techniques. Okay. All right. So types of flux. There are two types of flux, which is the base flux. All right. And then an oxidizing flux. Okay. So base flux is the sodium carbonates ke hydroxides. All right. For alkalines, you are going to look at the pyrosulfates, boric oxide, or fluoride acids. Okay. Oxidizing flux, also you can look at into the sodium peroxide, nitrate alkaline metal, and sodium carbonate. But the disadvantages of this using of flux is that contamination by the flux material, as what we have looked at before. When you put into something, for example, just a simple example of apa the 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 digestion using acids. So if your acids is not a very high purity, then it will introduce a contamination. So this is also the same as for using flux. Okay, so contamination by flux material, which high salt content, also may complicate the analysis. All right. Very high temperature when you place it in a crucible also may result in loss of analyte by evaporation. Okay. All right. So that is for flux. And then now we are going to, the last part of it, we are going to look at into the errors in sample dissolution. All right. There are several sources of error which are encountered in the sample dissolution step. Okay. So incomplete dissolution of analytes. So this is what I've mentioned before. Incomplete dissolution leads to an error because when you are trying to aspirate it into your flame AAS, the solids might be might be lodged in the tube. All right. So this is incomplete dissolution. Losses of analyte due to the volatilization. This is also an example of error in sample dissolution. Okay. External analytes, which is from the solvent, which is we call solvent contamination. Okay. We introduce for this, we expect it to dissolve our analytes, but this addition of solvent might have a solvent contamination where it might interfere with your analysis later on. Okay. The last one is the contamination from the reaction of the solvent with the vessel walls. All right. So some reaction solvents will react with the vessel wall as well, which could introduce a interferences inside your analysis. All right. So the last slide is that for the recovery. So recovery is a measure of amount of analytes in the assay relative to the amount of analyte inside the sample. Okay, so you can measure on how much of the analyte that you've got back in terms of the recovery. Acceptable criteria is usually around 80% to 120%. So how are you going to measure the recovery is by the concentration of the spike sample minus the concentration of unspiked sample divided by the concentration of the spiked sample times 100. Okay, for the recovery, I think that you are going to be looking it into much more depth, more, I think, in the validation lecture after this. All right. So for this one, I think that maybe we can look it into depth inside the uh, lecture. Okay. So all right, so now it's 9:50. Up until this point, is there any question? Ada soalan ke?
Doctor, the spike sample means that the sample that has been being processed lah, is it? In
Oh,
this
okay.
case.
Spike sample here is that when you place the with your sample with the analyte of interest, means that you for example you have the sample for the analysis of copper. So you don't know in terms of what is the concentration of the copper inside your sample. So you spike with the known amount of copper. So when you've got your graph later on, I think this is going to be explained much more better inside the validation, because at that after this, we are going to look at standard addition method where you are going to learn about the spiking of the sample. Because I need to show you the graph as well. When you spike, you've got a much more higher signal. Then you need to You need to look at the graph later on lah. Spike sample means that you spike your sample, you add a new, not a new lah, a known concentration of analyte onto your sample due when you want to measure your analyte later on. Okay.
Uh, okay, doctor.
All right. Is there any more question? Okay. Quiz 2. All right. So somebody did ask me about quiz 2. So quiz 2 is going to be from chapter 1 until chapter 5 lah. Sorry, chapter 1 pula. I think that quiz 1 we have done from chapter 1 and chapter 2. And then for quiz 2, we are going to look at chapter half of chapter 2, because the quiz 1 we have looked into up until auxochrome kan. So chapter 2 is after auxochrome until chapter 5 lah. All right. Is there any specific date for test 1? I have not yet have the date, but usually it's going to be on our last class lah, which is on on Thursday, which is during this time. Okay, is there any more question? Oh, okay. Okay, 30th you have another quiz Okay, never mind. 30th of November we have a test. We're afraid it might be clashing. Okay, never mind. I will just later on I will put the dates inside the WhatsApp group, so then we will discuss lah when is the suitable time. But usually, because as I've said earlier that and I also ask you if it is better when you are going to do your test or quiz. So you say that you want to do it in class, so it's going to be on Sunday or Thursday lah, it depends. Okay, Doctor, the quiz will be on Sunday. The quiz will be on Thursday. Thursday next week. Because on Sunday, I would need to finish up on chapter 6 after this. So on chapter 6, we are going to look at all of the parameters lah for including this recovery as well. Okay? All right. If there is no more question, that maybe we can end our session now. Okay, thank you everyone.
Betul.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Ya, Doctor.